This is Zehua Zhao here, and I'm submitting my late version of homework 2. Before that, I will show you my room to ensure that there's no cheat sheet hiding around. Here is the lecture 2 slide I was reviewing. I will now cut it to the the late version of homework. Alright, now we can see that we're trying to solve homework 2 late version with the problem statement on the screen. And I will start writing as I explains it. In the question, we can see that one end is fixed on the wall while the other end is pulled by the weight. So essentially, this string have both ends fixed and is a standing wave. It has two antinodes. From this, we can solve the wavelengths with the given length of the string. We know that horizontal part is 3 meters, so we have L equals 3.0 meters. And lambda, which is wavelength, is 2L divided by N. While N here is 2 with the two antinodes, we can get that lambda equals L equals to 3.00 m. Here you can see this part. Moving on a little bit more, we can list out the equation for energy of one cycle in standing wave. It's a quarter of omega squared times density times a squared times lambda. And we can know that the omega squared is essentially 2 pi times f squared. Having a little bit of change, just moving variables a little bit around and plug in the fact that we know f times frequency times lambda equals to v. We can get this to transform into an equation that's much easier to solve. As we can see over here, we will get this and thus canceling out, well, I haven't got there yet, but with the identity of velocity, I can cancel out the density, which is not given. V equals square root of tension divided by density. Plugging that in, I can get pi squared T divided by lambda a squared. Since we know what E is, it's 40 mJ. We can set up the equation of 40 times 10 to the negative 3 to the negative 3's power equals to pi squared times T, which is gonna be mg, and divided by lambda, which is 3.00 meter, and A squared. mg equals to 2.50 kg times 9.81 meters divided by second squared equals to 2.50 times 9.81. You can see it here. And with these two steps ready, we now have every single constant or every single variable solved that we can plug in to get the final variable of A. Notice here I didn't use the exact formula we were instructing in class was A divided by 2 of adding the two standing waves energy together, two wave of the standing waves energy together, because it asks for the amplitude of the standing wave, and this would be the easier way to solve it. So I essentially just added the energy of the two together and use the simplified formula here. Having everything moved to the same side and dealt with, we will get 3 times 4t times 10 to the -3 divided by pi squared times 24.525 equals to 'We'll get this. And then the rest would be simple plug and chug into my calculator, which would yield the number of, hold on 1 second please, 24.525. No. A equals 0.02 meter. This will be A. And that would be it for my video. Thank you for watching.